Imagine choosing your child's eye color, height, intelligence, and even immunity to disease before they're born. This isn't science fiction. CRISPR gene editing technology has made designer babies possible. Scientists can now rewrite DNA with unprecedented precision, creating ethical debates, social dilemmas, and a future where genetics could be engineered like software. In this video, we're breaking down CRISPR, the science behind designer babies, and what this means for the future of humanity. Before we get started, if you want to understand how genetics is entering the age of customization, hit subscribe. This is where science meets the future of life itself. What CRISPR actually is? CRISPR is basically molecular scissors for DNA. It lets scientists cut, delete, or replace specific genes with incredible precision. The full name is CRISPR-Cas9, and it works like a search and replace function in a word processor, except it's editing the code of life itself. Scientists can now target almost any gene they want and change it. Before CRISPR, genetic engineering was incredibly difficult, expensive, and unreliable. It could take years and millions of dollars to make a single genetic change. CRISPR changed everything. It's cheap, fast, and accurate. A basic CRISPR kit costs a few $100s. High school students have used it in science projects. This technology went from science fiction to widely accessible in less than a decade. What does this mean for babies? Every trait you have, from your eye color to your height to your risk of certain diseases, is coded in your DNA. CRISPR gives us the power to rewrite that code before a baby is even born. We're not talking about the distant future. This capability exists right now. The diseases we could eliminate. Let's start with the positive side, because it's genuinely incredible. There are thousands of genetic diseases that cause immense suffering. Things like sickle cell anemia, cystic fibrosis, Huntington's disease, and muscular dystrophy. These conditions are caused by errors in DNA, and CRISPR could potentially fix those errors before a child is born. Imagine parents who carry genes for a deadly disease being able to ensure their children never inherit it. No more watching kids suffer from conditions that destroy their bodies and cut their lives short. This isn't theoretical. Scientists have already used CRISPR to correct genetic defects in human embryos in laboratory settings. The technology works. We could eliminate entire categories of inherited diseases within a generation. Beyond genetic diseases, we might be able to reduce the risk of common killers like heart disease, Alzheimer's, and certain cancers by editing genes that make people more susceptible. This is the medical miracle side of the equation. CRISPR could end enormous amounts of human suffering. It could save millions of lives and prevent pain that currently has no cure. Where the line gets blurry. But here's where things get complicated. The same technology that cures disease can also enhance traits that have nothing to do with health. Scientists already know genes associated with height, intelligence, athletic ability, and physical appearance. If we can edit genes to prevent disease, what stops us from editing genes to make smarter, taller, or more attractive children? This is called genetic enhancement, and it's where the debate gets intense. Some people argue there's nothing wrong with giving your child advantages. Parents already do this by choosing good schools, providing nutrition, and encouraging talents. Isn't genetic enhancement just another tool to help your kids succeed? Others say this crosses a fundamental line. You're not improving your child's environment. You're changing who they fundamentally are without their consent. You're making irreversible decisions about another person's body and mind before they're even born. And there's no clear boundary between treatment and enhancement. Is fixing a gene that causes severe depression a treatment? What about editing a gene that makes someone slightly more prone to sadness? What about editing for happiness or confidence? The designer baby marketplace. Let's talk about what happens when this becomes commercial. If genetic editing becomes available, it won't be free. It'll be expensive, at least at first. Wealthy parents will be able to afford genetic enhancements for their children. Poor families won't. We could create a genetic divide where rich kids are literally genetically superior to poor kids. Better immune systems, higher intelligence, better looks, longer lifespans. This isn't just inequality. It's biological inequality that gets passed down through generations. The children of enhanced parents would inherit those enhanced genes. Over time, you could end up with a genetic upper class and a genetic lower class. This sounds like dystopian science fiction, but the technology to make it real already exists. And it gets worse. What happens when countries start doing this? Imagine a nation that decides to genetically enhance all its children for intelligence and physical strength. They could create a genetic advantage over other countries. This could spark a genetic arms race where nations feel forced to enhance their populations just to compete. The geopolitical implications are terrifying. What actually happened in China? Remember the twin girls I mentioned? Scientist He Jiankui used CRISPR to edit embryos, making them resistant to HIV. The scientific community was outraged. He broke ethical rules, lacked proper consent, and the edit wasn't even necessary. The targeted gene affects brain and immune function, so long-term effects are unknown. He was jailed in China, but he proved it's possible. Genetically edited humans now exist. The genie is out of the bottle. The mistakes we can't undo. CRISPR is powerful but imperfect. It can make unintended DNA changes, called off-target effects, which could cause diseases or disabilities. Edits in embryos are permanent, affecting every cell, and mistakes can't be undone. Genes work in complex ways, so changing one trait, like intelligence, might increase risks elsewhere. There's also the issue of consent. Children have no choice, and they may resent permanent modifications made before they were born. The ethics we're ignoring. Genetic editing raises deep questions. What makes us human? And who decides which traits are better? Cultures value traits differently, and many people with genetic conditions see them as part of their identity. Editing out traits like autism or deafness risks, sending a message that those lives are less valuable. It also threatens genetic diversity, which makes humanity resilient. Too much uniformity could make us vulnerable to disease or environmental changes. What happens next? Most countries currently ban genetic editing of human embryos, and scientists call for a global moratorium. But enforcement is nearly impossible. Some nation or rogue scientist will push ahead. Designer babies could become common in the next 10 to 20 years, where laws are lax. The real question isn't if it will happen, but how we respond. Ban it and risk underground use, regulate it carefully, or embrace it and try to make it fair? There are no easy answers, and time is running out. What makes CRISPR revolutionary isn't just its power. It's the ethical tightrope humanity now walks. We can cure disease, prevent suffering, and create possibilities never imagined. But at what cost? The question isn't just what we can do, but what we should do. So tell me, would you edit your child's genes if you could, or should nature take its course? Drop your thoughts in the comments. If this video gave you a glimpse into the brave new world of genetic engineering, don't forget to like, subscribe, and share it with someone curious about the future of life itself. Thanks for watching. I'll see you in the next one.